We're all dreaming about putting boots on Mars. It feels like the next great human adventure. But to really get a handle on the insane challenges that lie ahead, we've actually got to look back, way back, to our most terrifying moment in space. A mission that came this close to disaster, just a few days from Earth. That quote, man, it just puts everything into perspective, doesn't it? We celebrate the moon landing, as we should, but we often forget it was also the scene of our greatest close call. And that single event, the incredible story of Apollo 13, holds all the critical, hard-earned lessons we have to learn before we even think about touching down on the red planet. Apollo 13 has this famous nickname, the successful failure, and it fits perfectly. I mean, they never made it to the moon, but the fact that they brought that crew home alive, that became the gold standard for how to handle a crisis. It's the benchmark for survival right here in our own cosmic backyard. But, as you're about to see, Mars? Well, Mars isn't the backyard. It's a whole different universe of problems. So let's just do a quick flyby of what happened. The launch goes off without a hitch. And then, 2 days in, bam, an explosion absolutely cripples their main spacecraft. Through some of the most brilliant on-the-fly thinking in human history, the crew and mission control jury-rigged the lunar module into a lifeboat. We're talking about scrubbing CO2 out of the air with duct tape and cardboard. After 6 days of pure terror, they somehow made it home. Now here's the key takeaway. All of this incredible life-or-death problem-solving happened when they were just 3 days away from home. And that right there, that proximity to Earth, is the first gigantic difference we have to wrap our heads around. Because going to Mars isn't just a bigger step. It's an unbelievable marathon through a completely unforgiving void. The distances are so huge, they're almost impossible to truly comprehend. Let's just look at the raw numbers, because they tell the story. The moon? About 250,000 miles out. A 3-day trip. Mars, on the other hand, even at its closest approach, is 140 million miles away. That's a 7-month journey, just one way. Now, I want you to imagine that Apollo 13 explosion again, but instead of it happening 3 days from home, it happens 4 or 5 months out in the black. There is no lifeboat, there is no turning back, there is no rescue. Period. 250 days. Just let that number sink in. That's the best-case scenario for a one-way trip. And that number, it tells you everything. The real problem isn't just the distance itself. It's the commitment. The second you fire those engines for Mars, you are completely, totally, utterly on your own. But that crushing distance isn't the only enemy out there. There's another threat, an invisible one that gets worse and worse with every single mile you travel away from the safety of Earth. And that's the environment of deep space itself. So here on Earth, we live inside this amazing protective bubble, right? Our planet's magnetic field acts like a giant shield, fending off the most dangerous stuff space can throw at us, like these things called galactic cosmic rays. Now, the Apollo astronauts, they only dipped their toes outside the shield for a few days, but on a months-long trip to Mars, you are fully exposed to this relentless, cell-damaging storm of high-energy particles. And this is where it gets really stark. Just look at this chart. That first little bar, that's your average radiation exposure over a whole year on Earth. The next one, a bit bigger, that's an entire Apollo mission. Okay, now look at the estimated dose for a round trip to Mars. It dwarfs the others. It's not even in the same ballpark. This goes from being a manageable risk to a fundamental mission-defining challenge that, frankly, we haven't solved yet. Okay, so let's bring it all back. Let's connect these dots. What does the story of Apollo 13, that successful failure, this incredible tale of equipment and human ingenuity, what does it really teach us as we get serious about planning a mission that's exponentially harder? The biggest lesson is that you have to completely flip the script on how you think. Apollo 13 was saved by reactive genius, right? Brilliant people on the ground working a problem in real time. For Mars, it's not an option. You can't just radio Houston when a round-trip message can take up to 45 minutes. Imagine sending a text in an emergency and waiting 45 minutes for a reply. It means things like redundancy, self-repairing systems. They aren't just nice-to-haves, they are the mission. The ingenuity that saved Apollo 13 can't be a reaction. It has to be engineered, baked into the very DNA of the spacecraft before it ever leaves the ground. And at the end of the day, this is what it all boils down to. Apollo 13 proved we could survive a catastrophe when we still had that lifeline, however thin, back to Earth. The true challenge of Mars is building a mission that can survive total, complete, absolute isolation for years at a time. So that's the question I want to leave you with. Apollo 13 proved we could improvise our way out of a disaster when it was practically in our backyard. But the journey to Mars, the Red Frontier, it demands something else entirely. It demands that we build a machine, a system, that's already prepared for the unsurvivable. Now that is the challenge.